Good day everyone. So welcome to my YouTube channel, the Mom Gel channel. So for today's video, we will be discussing about principle of mathematical induction. So let's define first what is mathematical induction. So at its core, mathematical induction is a proof technique. It helps us establish the truth of statements for all positive integers. In essence, if we can prove something for a specific value, these are the basis steps, and show that if it holds for any integer, it also holds for the next one, the inductive step. We can confidently assert its validity for all positive integers. So to further discuss it, what is the basis step and the inductive step? So let's proceed to the first one, and this is the basis step. So in basis step, this is where we prove the statement for the smallest positive value, typically 1. It's the foundation upon which the inductive step builds. An example will make this clearer. So let's proceed to inductive step. So the inductive step is where the magic happens. We assume the statement is true for some arbitrary integer k, and then prove it for the next one, the k plus 1. This recursive process allows us to extend our proof to all positive integers. So to further understand it, I will be providing an example for this. So let's proceed. So our example is the statement to prove 1 plus 2 plus 3 plus n is equal to n times the quantity of n plus 1 over 2. So our first step is the basis step. So all we need to do is to change our statement to prove by n equals 1. So all the n that you can see here, you will just replace it by 1 and then solve it. So for n equals 1, the left side of our equation is simply 1, and the right side is, as you can see there. So if you replace it, I'll be using the doodle here. Wait, Mr. Doodle. So as you can see here, right here, so all we need to do is to, change n by 1. That is 1 times the quantity of 1 plus 1 over 2. So if you know the PEMDAS, so we will be starting by our parenthesis, the 1 plus 1. That is 2, but that will result to 2, and then times 1 is 2. So 2 over all over 2. So 2 all over 2, or it is simply 1. So since both sides are equal, our basis step holds true. So let's proceed to our inductive step. So inductive step. So assume true for k. So in our basis step, we replace n by 1. So in our inductive step, we will be replacing the n by k. So now, assuming our formula is true for some arbitrary positive integer k, we'll prove it for k plus 1. So we assume 1 plus 2 plus 3 plus k. Now we will, as what I said before, we will be replacing n by k. K is equals to k times the quantity of k plus 1 over 2. So let's proceed to our k plus 1. So now let's add k plus 1 to both sides of the equation. So as you can see here, we will just be adding the k plus 1 and the k plus 1 in the both sides of the equation. So by simplifying it, so as you can see here, it will result. So by combining the terms on the right side, we get k times the quantity of k plus 1 plus 2. So quantity of k plus 1 over 2 is equal to k plus 1, k plus 2 over 2. So, and this is exactly our formula for n equals k plus 1. So the statement holds true. So k plus 1 holds true. So thank you everyone for watching. I hope that you learned something today. Don't forget to like and click the notification bell so that you will be updated for my next videos. Thank you everyone, and bye-bye.